Happy New Year! This week, I'm still on break, but I'm resurfacing one of my favorite episodes on the Sexagesimal system and a viral Tesla math myth. What begins as a beautiful multiplication spiral becomes a story about Babylonian mathematics, misattribution, and why famous names so often eclipse the real origins of ideas. This one is definitely worth revisiting. Last month, as I covered a great deal of material on Tesla, I found this cool multiplication circle called Tesla's multiplication map. This multiplication map is a spiral of numbers with its innermost numbers representing a clock's layout. Then the next number outside of that first inner circle begins with 13, spiraling around, and eventually you have a large spiral of numbers that can go as high as you want, as long as each spiral of numbers is a multiple of 12. The beautiful thing about this spiral is that you can draw different shapes when you connect the numbers based on multiples of 2, 3, 4, 5, 6, and on and on. What is also fantastic about this spiral is that it uniquely teaches multiplication so that students can have an artistic visual of multiplication. I wanted to try it for myself, so I made my own multiplication map, building a spiral up to the value of 60. Then I drew out several shapes connecting numbers divisible by 2, 3, 4, 5, and 6. Each value gave me a really cool, different design. You can find this video on my Instagram feed with my handle, Gabrielle Burchak, or on my website at mathsciencehistory.com. A teacher in Arizona by the name of Joey Grether attributed this map to Tesla. Grether intentionally named it Tesla's multiplication map because the name Grether's multiplication map could not seem to gain traction. He designed it to look like an old document and titled it Tesla, Map to Multiplication. Then Grether fabricated a story that a local artist by the name of Abe Zuka found it at an antique shop in Phoenix. According to Grether's story, Zuka shared it with Grether, who, quote, had a few breakthroughs, unquote, stating that the map, quote, offers a comprehensive visual understanding of how all numbers are self-organized into 12 positions of compositability, unquote. This misattribution is called an eponymy. Eponymy is a theory or an idea that is named after the wrong person, which is usually the person with the most notoriety. In Grether's case, he intentionally named it after Tesla to gain internet traction for this map. Eponymy comes from the evidence that shows how celebrated scientists get more credit than unknown researchers do. American sociologist Robert Merton called this the Matthew effect, which he referenced from the Bible verse Matthew 25:29, which states, quote, for whoever has will be given more, and they will have an abundance. Whoever does not have, even what they have will be taken from them, unquote. The correlation between eponymy and Merton's Matthew effect are referenced in Stigler's law of eponymy. Dr. Stephen Stigler named Merton as the discoverer of Stigler's law of eponymy in his paper of the same name published in 1980. This paper was a tribute to Merton from Stigler when Merton retired in 1979. His paper's title was a clever joke on Stigler's behalf based on Merton's theory. The female term of the Matthew effect is called the Matilda effect. However, the name Matilda effect did not come from a Bible verse. Instead, the Matilda effect was named after Matilda Jocelyn Gage, who was born in 1826 and was a suffragist, an activist, and an organizer of the Women's National Liberal Union. For my longtime listeners, you might recall my October 2019 podcast on the Matilda effect, which provided a large list of female scientists that prestigious organizations intentionally overlooked. One such scientist includes Dr. Vera Rubin, whose work on dark matter earned Dr. James Peebles the Nobel Prize in Physics. Another noted female scientist includes Dr. Marie Curie. She won her first Nobel in 1903, but only after her husband, Pierre, advised the Nobel Committee that Marie had a significant role in her discoveries of radioactivity. Then there was Dr. Rosalind Franklin, a British biologist and DNA pioneer. Though she discovered the structure of DNA, she never won the Nobel for her work. Instead, the male members of her team won the Nobel in physiology or medicine. In ancient history, one of the first known misattributions comes from 300 CE when the mathematician Pappus referenced another mathematician by the name of Pandrosian. Historical writers had identified Pandrosian as a man. However, Pandrosian was one of the first known female math professors.
We'll be right back after a quick word from my advertisers.
Other earlier known forms of eponymy include the Fibonacci sequence, which is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and on and on and on. This sequence is a list of numbers first attributed to Fibonacci by the mathematician Eduard Lucas in the late 1800s. Lucas noted that each new number is equal to the sum of the previous two numbers. However, this sequence was first presented in 200 BCE by an ancient Indian author, Acharya Pingala. Then we have the Hasse diagram, which is a mathematical diagram used to represent a finite partially ordered set. This diagram is a 2- or 3-dimensional object where a point connects each line. Each of those points represents an element in the set that is partially ordered. These diagrams are attributed to Helmut Hasse. However, the mathematician Henry Gustav Vogt first used these diagrams 3 years before Hasse was even born. Then we have Newton's first law of mechanics, which states a particle in motion will continue to move in the straight line at a constant speed unless that particle is acted upon by an external force. He published this law, among other laws, in his work Mathematical Principles of Natural Philosophy in 1687. However, Newton's first law of motion is also known as Galileo's law of inertia. Many decades earlier, Galileo figured out that a body of motion will remain in motion unless something like friction will cause it to rest. Another eponymy includes the Belinsky dodecahedron, which is a 12-sided complex polyhedron with congruent rhombic faces. The Belinsky dodecahedron was named after Stanko Belinsky, a Croatian mathematician who rediscovered it in 1960. However, in 1752, John Lodge Cowley, a cartographer, geologist, and mathematician, originally presented this particular 12-sided complex polyhedron in his book Geometry Made Easy. Finally, we have the Pythagorean theorem, which is attributed to the Greek philosopher Pythagoras. The Babylonians had been using this theorem for 1,300 years before Pythagoras was even born. The Babylonians knew that the square of the hypotenuse is equal to the sum of the squares of the two sides. Additionally, other cultures used this theorem as well. For a visual, I will post on my website at mathsciencehistory.com a picture of a cuneiform tablet that shows evidence of the Pythagorean theorem from around the year 1700 BCE. The Plimpton 322 tablet from 1800 BCE is a clay tablet with numbers etched into 4 columns and 15 rows. What may look like a random set of Semitic cuneiform etches is really a list of numbers representing Pythagorean triples, which are a list of numbers that represent the length, width, and diameter of a right triangle. When deduced, all of these values show that the square of the hypotenuse is equal to the sums of the squares of each side. This has some of the oldest evidence of their use of base 60 and of the Pythagorean theorem long before Pythagoras was born. I will also post an image of that clay tablet, the Plimpton 322, on my website at mathsciencehistory.com. I think it's fascinating that the multiplication map, the spiral, uses foundations in Babylonian mathematics and uses components of base 60. That is why I built my Instagram multiplication map up to the value of 60 and a printout for you up to the value of 120. For those who have not heard my previous podcast where I talk about base 60 is a sexagesimal numeral system. What that means is that instead of using 10 as a base for all mathematics, early mathematicians used 60. For us today, we break down our numbers based on units of 10. We learn in elementary school how to count to 10 using our fingers. When we do addition, we add in base 10, carrying the values over once we exceed 10. However, in ancient Babylon, when they added in base 60, they carried the values over when they exceeded 60. Conducting math in base 60 lasted for hundreds of years into the 7th century of our current era. It may seem like this value of 60 is hard to comprehend because it is such a large number, but they managed to make it work. The Sumerians and the Babylonians also counted to 60 on their fingers. Looking at your right-hand pointer finger, you will see that your finger has 3 segments between each joint. Each of those segments on the finger is called the phalange. When you use your thumb to touch each phalange on your right hand, starting with your pointer finger, you will be able to count up to 12. Now, as we continue to count, we use the left hand digits to count for every value of 12. When we do this, we count to 12 5 times, which equals 60. As for the attribution to Tesla for the multiplication map, I think that Grether should have gone further back to 2000 BCE, to those who first did math in base 60, the Sumerians. Base 60 has been around for over 4,000 years. Even in the 4th century BCE, other cultures worldwide, including the Akari people of Indonesia, used base 60. However, base 60 has significant value in our current mathematics. It is the heart and soul of mathematics. Base 60 is still used today to measure geographic coordinates, determine the time on our clocks, and study angles in geometry and trigonometry. When we fall into a deep sleep, our hearts beat at around 60 beats per minute. And in a study done at Ruhr University, Bochum, cardiologists found that music that plays at 60 beats per minute, like Mozart's Symphony No. 40 in G minor, reduces stress and increases your relaxation, which helps you to study and retain information. If you would like to print out a copy of my Sumerian Sexagesimal Spiral, please visit me at mathsciencehistory.com. I have decided to reattribute the name of Tesla's multiplication map to the Sumerian Sexagesimal Spiral. It is official because the evidence of its use of base 60 is irrefutable. And it is official because I am the last person to name it so. So thank you, Dr. Stigler, for the idea. This is my eponymic contribution to the world of math, science, and history. Thank you for joining me at Math Science History. Please remember to subscribe to the show. Also, if you could leave a rating or a review, it would be so appreciated. Those ratings and reviews really help to increase my listenership, which help me to get more sponsors, which help me to keep the podcast up and running. If you want to learn more about the history of math and science, please visit me at mathsciencehistory.com. And if you like what you're listening to, please feel free to click on that cup of coffee image and buy me a cup of coffee, or 2, or 3, or 4, because every cup of coffee that you buy helps me to pay for the expenses that go into making this podcast. Also, if you're interested in leaving me a comment or chatting with me, you can always find me on your preferred social media platform, including Instagram, Facebook, LinkedIn, and Goodreads. Just search for Gabrielle Burchak. Until next time, Carpe Diem!